your textbook 5A. Key thing about absolute value is the distance from 0, meaning the absolute value of -4 is 4, and the absolute value of +4 is 4. Absolute value of 5 is 5. It's the distance from 0, and absolute value is always going to be, when we think of it, positive. Unless you have a negative out in front of that, which we're not going to be having. So when we graph an absolute value equation, so you guys might finish watching some of this online. This is really a piecewise function. You're going to have two pieces. The absolute value means it's broken into two pieces. The first piece is when y equals x. So if when y equals x, that's just telling us it's 0. This is kind of my dividing line, right? If y equals x, that means the slope is at y-intercept is 0, and it's going up like this. Please draw that as you are looking at yours. Right? If I'm graphing this, this tells me a start point of 0, 0. Slope equals 1 over 1 up. This equation tells me up. It starts at 0, 0, and my slope here is -1 over 1. Okay? So when we look at this, we are not going to go down this way because we're only looking at the values for negative, right? This was only my positive. Here, when we look at this, we are only looking at this part, right? Right in here. So if I get a negative slope starting at 0, 0, that means up 1. And my absolute value function, if I would pick values, sometimes we have different ones behind there. If I would pick values like -1. If I pick -1 here, the absolute value of -1 is 1. If I pick 0, absolute value of 0 is 0. So I have this point, I have this point. If I pick +1, it's 1. If I pick +2, it's 2. So it says this function is considered what we call the parent function. It describes the shape. If we are going to describe it, it is definitely not linear, right? So anytime you have absolute value, please write this in your notes. And we are on the bottom of page 27. Anytime we have absolute value, it is going to be a V-shaped graph. The vertex is at the origin meaning 0, 0. That's because there's nothing added here. It is going to always open upwards if it is positive. It is not linear, but the shape is made up of two linear rays. So if you notice that, you have one ray going off one side and one ray on the other side. If you would go to just Desmos graphing calculator, and you want to put in an equation like the last one we just saw, which was y equaled, and you can choose the absolute value. There it is. It's right below here. Choose absolute value of x. And I'm going to hit that again so I can get that equation. You could change this to put other equations in to help you out. So I want you to take a look at this one, and what we are looking at is, first thing we want to think about is, what is our piecewise function starts the left part of the graph, what would be the equation for that part? So if we were just doing the left side, that means this part right in here. What's the y-intercept? On the left side, it is parallel 0. What is our, if we are taking a look at this, what is our slope? What would you say as you are looking at that, Nathan, of that left side? 1. So my equation is going to be y equals -x plus 0, or just y equals -x. That's the left side. Agreed? Okay. We're going to look at the right side.
If we are looking just at the right side, so we're only looking here. If I would extend this, Olivia, what would you say my y-intercept is? -2. So I know my y-intercept back here is -2, and I have to have an x. And if I was looking at it, Grace, what would you say our slope is on the left side? 1. So it says write it as a piecewise function. So our piecewise function, and again, I don't care if you decide to use f of x or y equals, we're going to have 2 pieces. What's the dividing point as I am looking at that, Claire? Where is the number that it changes? At what?
1.
At x? Right. X equals 1, right? And when we take a look at this one, we might go less or equal to 1, and maybe x is greater than 1 for the 2 sides. The first one is going to be -x. The second one is going to be x minus 2. This point right here is our vertex. Andrew, where is that located? Ooh, careful. +1 and then -1. So it says there are 2 ways that we can write this. As a piecewise, like here, or using absolute value, which is shown right here. I want you to take a look. When the slope is 1, this is in front here is a 1, right in front of that x. Doesn't this remind you of a form we've already done? Only thing in the form on the quiz, what did we have instead of the absolute value? We had parentheses, right? Isn't this the same? If we are looking at this, I want you to think about this. This is like our, if we look at this equation, this is really like our point slope form. Only thing it has absolute value instead of a parenthesis. So if we look at the positive case of this, right? Notice this is positive, okay? So when you take a look at this, please write positive case. As we look at that positive case, that means this is positive -1. You combine your like terms on this side, and you get y equals x minus 2. That's this part. If we take this absolute value and we do that negative case, remember when we were solving absolute value, we always divided it into 2 things and said it's either positive or negative. So this time we're going to change and not put absolute value. We're going to put a negative, but we're going to put that whole thing in a parenthesis, x minus 1. That means that becomes a -1 and a +1. When I add these like terms, I get the same equation as I did here. So for a lot of people, writing a piecewise function or writing it this way, this is way easier because this 2 numbers tells me, remember, point slope form, y equals mx minus x1 plus y1. Look at this point, that's my y1, right? And here, this is my x1. Only thing now, instead of parentheses, it's absolute value. So this is a form we're going to continue to use and use and use. So, the next page, or the bottom of this page, I should say, as we look at this. So it says, linear functions can be written point slope, which is sometimes referred to as linear vertex form, even though it doesn't have a vertex. The reason is that it looks almost identical to the vertex form of absolute value. Here's our linear one, slope of 1, y-intercept, they just picked a point, right? This is the point -1, 2. They wrote it this way. Notice this same point now is our vertex. What does it look like in absolute value form? 1 out in front. Why? Because the slope is 1 and -1. X minus, it was a -1, so it's +1 because it would have been absolute value of x minus a -1, but we don't like that minus a negative, so we change it to a plus. And then the y point is 2. So the question asks, notice these 2 graphs as we are looking at these equations. So what do we notice about them? If we look at the two things, what we notice is that the y, write down, equals mx minus x1 plus y1, and y equals m absolute value of x minus, this is how they write it now, h plus k. But this is really the x point of your vertex. And this is the y of your vertex. And it's always an x minus and a plus y. So the only thing different is that this tells you h, k is your vertex. That is a wonderful thing. It's like so beautiful. You're like, what? It's so nice if that's it. So I always know I can start here at a slope of up 1 and over 1 for my slope. And this also tells me the slope on this side is going to be negative 1. So one side has a slope positive 1. This side has a slope of negative 1. They're always going to be just the opposites when we look at those slopes. Okay? So you're asked to graph these. Let's start. Where is our start point or our vertex? Okay? So if we are looking at the start, that means I want my vertex. I want the h, k, the x, y. Keep in mind that general form, right? The general form said y equals m, absolute value of x minus x1 plus y. So in this first one, Nathan, what do I think my x point is? 1 or negative 1? Negative 1. So, careful. Minus. This has a minus, so this should be positive. That makes sense? Okay. So what about the y point? Negative 3. So let's plot that point. 1, negative 3. That's my vertex. This one goes up, right? So I know the v has to go up. What is the slope out in front? The slope is 1. So from this point, I'm going to go up 1 and over 1. Up 1 and over 1. I'm going to have a ray. On this side, I'm going to have a negative slope. I'm going to go up 1, I'm going to go back 1. Yes, question?
So just ignore the minus between the x and the y.
Say it one more time.
You just ignore the minus between the x and the y.
The equation is always x minus. So if this is a plus, like here, that means this was because this was x minus a negative 2, right? So that's what Nathan was asking. He said, oh, this should be negative 1. Nope, the general form is a subtraction, not an addition. So if you see a minus, that's the general form. That tells you this, my x is at 1, right? Whereas here, it's going to tell me my x is, because it says plus 2, my vertex here is going to be at negative 2, right? Okay? And we're done. Could you pick values and check it? You could put this in your calculator, right? When x equals 3, you could plug in 3 minus 1 is 2, right? Absolute value of 2 minus 3, 2 minus 3 is going to be negative 1. That point works. This is at 3, negative 1. And you could do that for all those points on there. So, vertex here as we are taking a look. Stacey, what do you think? X minus what in the absolute value? 0. And so my vertex, right? I start down at 0, negative 5. What do I know the slope has to be, Andrew? 1. And it's on both sides. One side it's 1, the other side it's negative 1, right? So as we are taking a look at that, if you were going to help me graph it, so then what would you do from this point?
Up 1 over 1.
Yep, up 1 over 1. So piecewise, and on this side, up 1 and back 1. In front of it was positive, has to go up. Vertex, negative 2, and this one should be where? 1? It's still going up because it's positive in front. So I'm going to go over to -2, +1. If I plug that point in, if I plug in -2 here, and I add 1, this gives me 0 plus 1. That does come out to be 1. That's a point on my graph. The slope is 1. And you're done. And you don't have to make that table like we did before, right? So, I'm going to show you this one general thing, and I'm going to truly recommend that you go back and kind of watch the video because you hear it just a little more. I want to show you all of these, and I want to try and look at one of the questions, but I just want to show this to you. So here's the deal. If this is positive in front of your absolute value, it's going to open up, okay? So when we talk about the graph opening up, what that means as we are looking at the problem is that when it opens up, as you look at this, your V will always go up, okay? If it is negative in front, anytime you have a negative, the V is going to go down. You're still going to have the same slopes, like 1 and -1, 2 and -2. It's just that the positive V will go up, the negative out in front makes it go down. This is how we find slope, right? So if your slope, again, slope is always rise over run. And as you look at that, if it's bigger than 1, it's going to make yours narrower. It's going to make the 2 V's, like it's going to make it really narrow. So like kind of going to be almost like this, okay? The steeper, the bigger it is. The smaller that is, or the fraction, it gets wider. So then your V gets almost like this. It widens out, okay? This is going to change the X location, right? So this is always the X location. So your point goes back to if it's a plus number, then that means it's negative. If it's always minus the number, then that's the positive number of it. So you have to have this equation kind of memorized. And the K is the Y. Okay, so the K is the Y. So I'm going to attach this video on EduCal, and then there'll be the one that's also in Google Classroom, right, where the other teachers are teaching it. So I'm going to have you, sometimes you might look at both and fast forward, whatnot. I'm going to go back to this in just a minute. Look at the next page, and let's try to do this one before we run out of time. First off, what is the slope? Slope is m equals 2. So the slope on one side is 2 over 1 going up, and on the other side, it's a negative 2 over 1, right? Where is our vertex? Oh, it's a plus. That means it's located at -1, comma, -2, because this had to be minus a -1, right? So that gives me -1, -2. I put the point at -1, -2. It says, what are the x-intercepts? These are going to be really important coming up. X-intercepts, when we solve quadratics, are our solutions to the quadratic, so you'll hear that later. But a slope of 2 means from here I'm going to go up 2 and over 1. Up 2 and over 1. Up 2 and over 1. Here's an x-intercept. On this side, the other side of it, right, this is my -2 slope, I'm going to go up 2 and over 1 this way. Up 2 and over 1. Here's my other x-intercept. So the question says, what are your x-intercepts? They're at -2, 0, and 0, 0. Later we call these solutions. Oh, domain. What kind of x values could you choose? This should be all reals, right? Does that make sense? Whereas my range starts at what number? Y greater or equal to 2. So a lot of times we might write the range this way. Y greater or equal to -2. Or you can write it out in words. I take it either way. I think this is a little quicker. Now, we didn't finish that last example in looking at the questions, but this one, you'll see it in the video online as you're looking at that one. And please make sure when you do this, you do the questions number 8, and you do a graph for number 8. And then you do like number 9. Some of you try to put them all on one. I don't want them all on one. I don't want one big coordinate grid with a bunch of V's all over, right? Because then I can look at this one and go, oh, this is a really wide one, right? Whereas this one is really going to be a narrow one, right? How do I know that? Because I can look at the slope. But I'm going to see those on your paper, okay? So